Hello again. Today we are going to talk about evaluating limits using algebraic methods. So if we look at 4x squared plus 6x minus 3, and we have a number that is approaching 2. So we're going to just plug in the number 2. So 4 blank squared plus 6 blank minus 3. Of course, we'll fill that in with a 2. And we get 4 times 4 plus 6 times 2. So remember your order of operations. You can just put this all in. If you have a graphing calculator, it'll do the whole thing for you in order. But you end up with 25. So the limit as x approaches 2 is 25, which makes sense. Nothing fancy there. All right, now we have some fractions. We're still going to just plug in, see what happens. So as x approaches 2, the function is going to approach negative 5 over 2. Or you can say negative 2.5, doesn't matter. Another one. Now it's approaching negative 3, which is fine. And we get 0 over negative 7. 0 divided by any number is 0. So when you plug in negative 3, as x gets closer and closer to negative 3, the output, the function, is going to be closer and closer to 0. Okay, now we're going to plug in a 4. And now we have a problem because, as you know, if we divide by 0, we can't do that. You can never have 0 in the denominator. So we're going to say now we have a problem. Now we have a problem. So this is a big no, we can't plug in negative 4. There's going to be no solution there. Okay, so you can also say, I guess no solution, you can say does not exist. So basically, if we get 0 in the denominator, this is something we can do. We can factor, simplify, and plug in. Okay? So, I'll show you what I mean here. So, if we have x plus 4 over x squared minus 16. So if I plugged in negative 4 squared minus 16, I would get 0 in the denominator. So that would be does not exist. Okay? In the last case here, that's our solution. Just doesn't exist. Because there's nothing we can do about that. But in this case, we're going to try to factor. So I can factor the top. Well, I can't. It's just x plus 4, but if I could, I would do that. I can factor the bottom, 2 perfect squares, x plus 4, x minus 4. I'll reduce that, so those cross off. And now it simplifies to 1 over x minus 4. So if I plug that limit in, so now if I plug in negative 4, I get 1 over negative 4, which is negative 1 over 8. So if you plug in a number and you get 0 in the denominator, try to factor it, simplify it, and then plug it in. So in this case, if an x approached negative 4, it would actually approach, the function would approach a limit of negative 1/8. In the case we did on the last slide, there was nothing we could do. But in this case, we were able to factor it. Okay, so I'm gonna try this again. Again, if I started out here, I would go 2 squared plus 3 times 2. Try this to begin with, because if it works, great. But in this case, we get a denominator of 4 minus 2. Oh, actually, this is fine. 4 minus 2 minus 12. So this is okay as it is, so we don't need to factor it. Two squared minus 2 minus 12. We end up with 10 on the top, negative 10 on the bottom. And so in this case, as x approaches 2, the function approaches negative 1. So again, kind of going back here, when we plugged it into the original, we got 0 in the denominator, and we can't have that. That's a big no. So if we get 0 in the denominator, try to factor it, simplify, and plug it in. In this case, we plugged in 2, and we did not get 0 in the denominator. So go ahead and plug it in just like we did earlier. All right, so we'll try a couple more. I'm just going to test this denominator. 2 squared minus 4. So I cannot plug that in as is. This is, oops, it's not a 0, it's a no. Okay, so I'm going to try to factor this. So my denominator is 2 perfect squares. Remember, when we factor this, think of 2 numbers that multiply out to be negative 14 and add up to 5. So 2 numbers that multiply out to be negative 14, add up to 5. That becomes 7, negative 2. So this is x plus 7, x minus 2. Look to see if we have any common factors top to bottom. So I can cross off anything that's inside the parentheses. Now I'm left with x plus 7 over x plus 2. And now if I go back and I plug in that 2, two plus 7 is 9, 2 plus 2 is 4. So we end up with 9 over 4. Now I can change it to a fraction, but I can just leave it 9 over 4 as well. Okay, so now I'm going to try a 9. What happens when I plug in a 9? So if I were to go 9 minus 7, I get 2. So it's like, oh, okay, this is okay. So I don't need to factor it. I could factor it, but I don't need to. I can just go 9 squared minus 49, 9 minus 7, and I would end up with 81 minus 49, which is 32 over 7. Okay? So if you're given a number, go ahead and plug it in as is, but the only problem is if you get 0 in the denominator, you can't, it's not going to exist as is. So try to factor it and see if you can get an answer or get a limit that way. Okay, so here the algebra gets a little bit more complicated. So what we're going to do in this case, we've got h minus 7. And again, I test this 0, and this is a big no, it's not going to work as is. I can't just plug in the top. Well, I guess, again, I want to try to factor it, simplify it, and then plug it in if I can. So I'm going to simplify this. So I'm going to multiply and simplify first. So h minus 7, h minus 7 minus 49 over h. So I'm going to do h squared minus 7h minus 7h. It's negative 7 times negative 7 is plus 49. All right, and these happen to cross off. So now I'm left with h squared minus 14h. I've still got the problem that if I plug in that 0, then I'm going to get 0 in the denominator. But notice I can factor the top. I can pull out a common factor of h. And now these will cross off. And now I can plug in a 0. 0 minus 14. I get a limit of negative 14. So if we plug in this, whatever they give us to plug in, if I end up with 0 in the denominator, I have to stop. I'm just going to stop, and I'm going to simplify and factor it. So before I was able to factor right away. In this case, I am not able to do that. No, I'm just going to erase this here for now. We already know this is a no. So this is 2x plus 3, 2x plus 3 minus 9. So it's a similar example to what we were just doing. This becomes 4x squared. 2 times 3 is 6. 3 times 2 is 6. 3 times 3 is 9. So it looks like something similar is going to happen again. We think. You never know. We end up with 4x squared plus 12x. These cross off. Common factor, I can pull out a 4 from the top. 4 and an x. So biggest common factor here is 4x. And this becomes 2x. So I can reduce this. X over x crosses off. 4 over 2 becomes 2. And now, it's like, what the heck were we even plugging in to begin with? 2 times 0 plus 3, which is 2 times 3, which is 6. So that is finding limits of functions algebraically. So kind of the key is you go ahead and you plug in what it says. However, if you end up with 0 and a denominator, you have to try to deal with that by simplifying, factoring the numerator and denominator, and seeing if you can reduce the fraction so you don't have end up with 0 in the denominator.